Good morning, students, and once again, welcome to the lecture of Science and Technology Part 2. Students, today we are going to start a new lesson, lesson number 5, towards green energy. So, let's start with the lesson. We are going to study the three important things in this lesson. The very first one is use of various energy sources. Okay, what are the uses of the various energy sources? Then second is generation of electrical energy, the various processes or the various methods by which the electrical energy can be generated. And third, the process of generation of electricity and environment. So all this we are going to cover in this towards green energy. The lesson is quite interesting. Now, at the beginning of the lesson, there are certain questions given like, can you recall? And the very first question is, what is energy? It's a type of revision what you have studied in the previous classes. So, what is energy, students? Yes, energy is the capacity to do work. Whatever capacity we have to do any type of work, whatever it is, that is called as the energy. Second question is, what are different types of energy? Mainly, there are two types of energy. The first one is potential energy and the second one is kinetic energy. Potential energy is due to the stagnant or stable condition, and kinetic energy is due to the movement or motion. So these are the two types of energy, potential energy and kinetic energy. Then the third question is, what are the different forms of energy? This answer to I think everyone can give. Even if you look around yourself, you can immediately give the different forms of the energy like heat energy, electric energy, solar energy, chemical energy, nuclear energy, mechanical energy. These are all the different forms of energy. I hope you know the law of conservation of energy, students. The energy can neither be created nor it can be destroyed, but it can only be converted from one form to another. It can be transformed from one form to another. Okay. So, next is energy and use of energy. Why do we need energy? Now, in the very first question, as we had seen, that capacity to do any work is energy. So, energy is the basic and primary need of every living organism, right? Because it is the capacity with which you can do the work. So, whatever work you are doing, we need energy, maybe in different forms. For different type of work, different type of energy is required. Mechanical energy, chemical energy, sound energy, light energy, heat energy. So these are the different forms of energy which are used to fulfill our requirements. So we need energy to do any type of work in different forms. Now, in this lesson, we are going to study about the various sources which are used to generate the electricity, the methods which are used, the scientific principles which are used to generate the electric energy, and also we are going to study the advantages and disadvantages of these methods. As you know that every coin has two sides. So if there are any advantages, then there may be certain disadvantages also. And lastly, we are going to study about what is green energy. What do we understand by green energy? Now again there are questions in the textbook. The very first one is, where do we use electrical energy in our day-to-day life? Yes, again if you look into your room, all around yourself, you can say the electrical energy is used in the various appliances such as bulbs, tube lights, fans, iron, refrigerator, cooler, AC, then television sets, tape recorders, computers, laptops, and what is in your hand? Your mobile phone, right? So that also is the like you can say it is also an appliance which runs on electric energy, right? We have to charge our phone, right? The battery inside the phone is to be charged, so the phone also runs on electrical energy. So these are the different uses in our day-to-day life. You know, we cannot even think of living without the electrical energy. Next question is, how electric energy is produced? Electrical energy is produced with the help of the generators, and the principle which is used in this, again you had studied about it in lower classes. If you remember, in 8th standard you had studied about the electromagnetic induction. Do you remember? Are you able to recall, students? Yes. So we use the principle of electromagnetic induction, and the magnetic field around the wires is changed, and due to the difference in the potential difference, the electric energy is generated. Okay, so this is all about electric energy production. Then we are going to study in detail generation of electrical energy. Now, generation of electrical energy. As I said, the electricity is generated with the use of principle of electromagnetic induction. Now, what is electromagnetic induction? Now, as you can see in the picture, the electric induction full picture is given. Now, I'll explain you the diagram. Now, before we start with the principle of electromagnetic induction, you should know that who invented this electromagnetic induction? Yes, any guesses? Michael Faraday was the scientist who invented the principle of electromagnetic induction. And this is the principle which is largely used in generation of electricity. Now, this principle is when a potential difference is generated across the conductor whenever magnetic field around a conductor changes. So, potential difference is generated when the magnetic field around a conductor is changed. Now, here the two-way field are produced around a conductor. Now, either keeping the conductor stationary or rotating the magnet. And second is keeping the magnet stationary and changing the field around the conductor. In any of the way it can be done. In both the ways, the potential differences is created across the conductor. Conductor is the coil. You can see the magnet and the rotating magnet field. And this side you can see the voltmeter through which we come to know that the electric current is generated. So, the electric generator is based on this principle. Now, how the generation of electric current takes place? Now, first in the generation plants, the large generators are there, turbines are there, okay, and then it generates the electric energy. You can see the picture of the turbine. Turbine is having the blades around itself, and when the liquid or gas or steam, whatever falls on these blades, the turbine starts moving. So in the generation power plant, the large generators are used, turbine is used, okay. Then as I told you that when the liquid or gas is directed or falls on the blades of the turbine, as you can see in the picture, it starts rotating. Why it rotates? Because of the kinetic energy. Whatever falls on it, whether it is liquid or steam, its kinetic energy rotates the blades of the turbine. Now this turbine is connected to the electrical generator, right? So the magnet in electric generator starts rotating and the electrical energy is produced. So this is how the electric current is generated in the electrical power plant. Then next is, you can see the picture schematic of electric generator. How the electric generator works. Now here the electric generation is based on the principle of electromagnetic induction, as I told. Now we have a generator, and to rotate the generator we need a turbine. And how the turbine is rotated? It is rotated with the help of an energy source. Now which energy source is used to rotate the turbine? On that basis the different power generating stations work, right? So now further we are going to study about the different types of electrical power stations where the turbine is rotated either with the help of the steam or with the help of the water. So one by one we will start with the different electric power plants. Now in very simple flow chart, it is shown how the generation of electrical energy takes place. Students, I always emphasize that you should always remember the flow charts or tree diagrams or ray diagrams, because it becomes very easy to understand and memorize the process. Now if you remember this very simple linear flow chart, you will be very easily you will be able to write the process of generation of electrical energy. Okay, so proper energy source to run turbine, which runs the turbine. The turbine helps in the rotation working of the generator, and then this generator produces the electrical energy. So this is the flow chart of how the electric energy is generated. Now we'll start with the very first one, thermal energy based electric power station. Now thermal energy is nothing but the steam, right? And from where do we get this steam? We get this steam from the coal. So the fuel or the raw material which is used in the thermal energy power plant is the coal, right? Now coal is heated, right? And then the heat energy is passed on to the water in the big boilers, right? Now in these boilers, the water is converted into the steam. Okay. Now this steam passes on to the turbines. And I hope you remember what happens to the turbine when any type of flow of gas or vapors or liquid takes place. It starts rotating, right? Now water is converted into steam in the boilers, and then from the boilers the steam is passed on to the turbines. So the turbines, they start rotating. Now this water is again turned back to the boiler. Okay. So the turbines in turn, they start moving the generator, and in the end the electrical energy is produced. So this is the flow chart of production or the generation of rather electrical energy with the help of the steam, right? That is why it is called as thermal energy power plant. Now first you have to remember this flow chart so that it becomes very easy for you to remember the steps, right? When you remember the steps, you will be very able to write the explanation of this power plant. Now one more diagram I had given you, that is again the ray diagram, where the energy transformation in thermal power plant takes place. Now how the conversion of energy from one form to another takes place, and it is at the end converted into electrical energy. Okay, if you remember in the beginning I had told you that the energy conversion mainly takes place in the generation of electrical energy. So we had taken the coal. Coal contains energy in the form of chemical energy, right? So in the beginning we are having the chemical energy in the coal. Then this coal is heated, right? And the water converts into steam, right? So now water is converted into steam, so it is called as the thermal energy. Steam energy is also called as thermal energy. Now this thermal energy is in the form of kinetic energy, right? Because it is not stagnant, it's moving, it's in motion. So this kinetic energy in the steam or the thermal energy, it rotates the turbine, right? So this kinetic energy which was in steam, it start moving the turbine, starts rotating the turbine, and then this helps in the generation of the electrical energy. So see, actually the first and the second, both the flow charts are same. Only in the upper one we had written the name of the, you can say the appliances. Boilers are there, turbines are there, generators are there. And in the second one we had written about the energy transformation. How the energy is transformed from one type into another. So chemical energy converts into thermal energy into kinetic energy rotates the turbine, and thus the generation of electrical energy takes place. Now again there are questions given in the textbook. The first question is why the energy in the coal is called as chemical energy. Yes, why it is called as chemical energy? Because in the coal the energy is present in the form of the chemicals, right? The atoms and molecules which are present in the coal, they are bonded together with the chemical bonds. This we had studied in the lower classes. So when the coal is burnt, this energy is released, and this energy in the coal is transformed into thermal energy. Okay. Then second question is why steam is used to rotate the turbine. Now when here in thermal power plant the water is heated, it converts into steam, right? Now this steam is under very high pressure and high temperature. So it has a great force. Now with this great force, this steam starts rotating the turbine. Okay. Then afterwards this steam is condensed with the help of cool water, and then again it is converted back into water, because when steam is condensed, again it turns back into water, it transforms into water. So In this way, the turbine rotates and hence it is used to rotate the turbine. The conversion of water is done into steam, and steam is under great pressure and temperature, and thus it is used to rotate the turbine. Then the picture you can see is the schematic of thermal power plant. Now first we will see what we observe in this picture. First we see that there are two big towers, right? So these are the two big towers. The very first one where the stack is written, and the second one the cooling tower. So these are the two towers. Then there is a boiler. Okay, obviously boiler means the water is heated here. Okay, and then you can see the turbine is there. Turbine is connected to the generator, and from here, from the turbines, the water goes to the cooling tower. There it is allowed to condense, and then again it is turned back to the boiler. Oh, this is the, you can say, the flow chart. This is how the journey of energy from the boiler takes place to the generation of the electricity. Now we will study in detail. Now what happens in the power station? The boiler, the chimneys, the turbine, the generator, the cooling power, all these are arranged in the shown diagram. Okay. One question, why the stack, that chimney is very tall? Yes, because when water is converted into steam, the different gases are given out. So these gases are released by a very tall chimney so that they do not create the pollution in the air of the lower layers. Okay. So in the boiler, the water is heated with the help of the coal, right? The chemical energy is used to heat the water. The water is converted into the steam, and in this heating of water, whatever gases are produced, they are released with the help of a very high chimney in the atmosphere. Okay. Now this steam has a large amount of kinetic energy, and it is passed on to the turbines. Now the turbine starts moving, okay, and as the turbine starts moving, the generator also starts working. Now once the turbine starts rotating, the steam which is used to rotate the turbine, its temperature and pressure, it decreases, right? And it is passed on to the cooling tower, where by the method of condensation, again the steam is converted into water, right? So this water in the cooling tower is circulated from the condenser. Then the energy which is in the form of heat in the steam, that condenses back the steam into water, and there are certain vapors and hot air released when the condensation takes place. So these vapors and hot airs are released through these cooling tower. Okay. So the electricity is generated in this way with the help of the thermal power plant. But though it is a major way of electricity generation today, but it has certain problems also. As I said, and as we know, that every coin has two sides. So if there are advantages, if we produce electricity, if we generate electricity with the help of the thermal power plant, there are certain disadvantages also. There are certain problems also. Now let's see what are the problems, what are the disadvantages of the thermal power plant. Yes, can you guess what will be the major problem of the thermal power plant? Yes, because the harmful gases are released. So the very first problem will be air pollution. Now, air pollution takes place due to the burning of coal, because coal is burnt, and this produces very harmful gases like carbon dioxide, sulfur dioxide, nitrogen oxide, which are very, very harmful for the living organisms. So this is the first disadvantage or first problem of thermal power plant. Second one is health problems. Now, air pollution has taken place. What do we respire? What do the plants respire? What do the animals respire? They take in air, that is oxygen, and they give out carbon dioxide. Now, when these harmful gases are present in the environment, present in the air, so definitely when we are going to inhale air, it will contain these harmful gases. And which system will be affected? Yes, it is the respiratory system, right? Because it is not only the gases which are given out, even the carbon soot particles, the black, very minute carbon particles, the unburned carbon particles, they are also released from the chimneys. And if you remember, we had studied that these carbon particles, when they fall on the leaves of the plants, they close the stomatas of the leaves, right? So they are not able to take in oxygen and give out carbon dioxide during respiration, as well as in photosynthesis, they take in carbon dioxide and they give out oxygen through the same stomata or pores. So both the processes are affected, right? And in human beings or animals, when they take in this harmful gases from the environment, their respiratory system is also have adverse effects. Okay, so second disadvantage or the problem is the health problem, and mainly the respiratory system disorders takes place. And as I said, then in plants also, because of the carbon soot particles, the stomatas, they get closed, and thus the respiration as well as the photosynthesis processes are affected. Then limited availability of coal, as we know that it is the conventional source of energy. So coal is present in very limited amount. And if you remember, in 9th standard, we had studied about the fossil fuel. So coal is a fossil fuel, right? So it is in a very limited quantity under the deeper layers of earth. So that is the major problem, because the reserves of fuel is very limited, and definitely in the future we are going to face the problem of scarcity of coal. So these are the three main problems of, or you can say disadvantages of the thermal power plant. And there is a table given in the textbook. Do you know some major thermal power plants in India and their capacity? This is just for your information where the thermal power plants in India are situated. One is in Madhya Pradesh in Vindhyanagar, and the capacity is given in megawatt. Then in Mundra, Gujarat. One more is there in Mundra, Gujarat. One is in Tamnar, Chhattisgarh, and the one is in Chandrapur, Maharashtra. Okay, students. So with this, we finish. We can say the first power plant, that is the thermal power plant to generate the electricity. Okay, students, the question answers of the lessons which we had already completed, I hope, and I am assured that you might have completed your notebooks. So take care of yourself, and in the next lecture we are going to continue with the lesson. Till then, take care. Thank you.